This is the portion of the function continued by S B Mishra. 8 number question. Solve this inequation. X minus 1 by x minus 3 less than 0. Less than 0 means select negative. The negative in between 1 and 3. There is a sign scheme starting positive from right side, then negative, then again positive. This sign scheme is a permanent sign scheme on number line. X is equal to 1 and x is equal to 3. How to find the 2 points on number line? These 2 points are called terminal points, or terminal point, or one more name is there, critical point. So how to obtain the terminal and critical point? So equate this factor to 0. X minus 1 is equated to 0, we get x1. X minus 3 is equated to 0, it gives x is equal to 3. So these two are the terminal points on number line. Display, follow the sign scheme, plus, minus, then again plus. Now select negative less than 0. Negative is selected. So 1, 2, 3. The answer is 1, 2, 3. So this is your answer. X belongs to 1, 2, 3. Remember it, there is one more restriction. Denominator is not 0. So x minus 3 is not 0. So x is not equal to 3. We have not taken x is equal to 3. So this restriction must be kept in your mind. Next, 9th number. Solve with equality sign. Equality means you have to take the two terminal points 1 and 3. 1 have to be taken, 3 have to be taken. But remember that denominator is not 0. So we are not supposed to take this 3. So we cannot take 3, and this is your answer. But you have to take greater than 0, means positive values. Positive values are this side and this side. In the above question, negative to negative we selected minus values, less than 0. But in question number 9 we have to select greater than 0. So positive values. So the answer is minus infinity to 1 selected, union 3 to infinite. Then 10th number question. Y minus 3 by y is more than equal to 0. Now again let y is written as y minus 3 more than 0. The two terminal points are displayed on the number line. One is 3, other is 0. Here there was a scarcity of terminal points, so I have expressed minus 0. So 0 and 3. Now denominator is not 0, so y minus 0 is not 0, so y is not equal to 0. But 3 must be taken. So due to this greater than, we select from minus infinity to 0, union 3 to infinity. Now 11th number. Solve the inequation with 3 factors. The 3 points are displayed on number line. One is minus 2, then minus 2 becomes 2, 3, 4. 2, 3, 4 have been displayed on the number line. Now since denominator is not 0, so never take x is equal to 4. But other point 2 and 3 must be taken. So start the sign scheme from plus, then minus, then plus, then minus. Now greater than 0 means select positive sign. So positive sign is this. So 2 to 3 union 4 to infinite. Now find the domain and range of this function. Y is equal to this. Since denominator is not 0, so this is not 0. So write and proceed the factorization, and hence x is not 1, x is not minus 1. So the domain is equal to real number minus these 2 points. So domain is ready. Now to find the range y is given. Now to find the range, express x in terms of y. Just see how x is expressed in terms of y. In terms of y is given. Y is given to you. Write x in left side, then cross multiplication, then find the value of x. Now we know that radicand, whatever inside the root is called radicand, is more than equal to 0. So go here. Y minus 1 by y is more than equal to 0, and hence more than 0. Denominator is not 0. So y is not 0. Now display these 2 points on number lines 1 and 0, 1 and 0, 1 and 0, already done earlier. So you have to select greater than 0 positive sign. So positive sign starts from minus infinity to 0 union 1 to infinite. This is your range. Find the domain and range of this function. This is a polynomial function, so domain is equal to real number, no loss. For range y is equal to this. Now write x first, then x is equal to plus minus root this. Now we know that radicand is more than equal to 0, so y minus 2 is more than equal to 0, so y is more than 2, so range is equal to 2 to infinite, no problem. And here is one more thing, the value of y is always positive, and this is also telling that the value of y is more than 2 is always positive, so the range is ready. Now 18 number. fx is defined in two ways. 0 less than equal to x less than equal to 2, and 2x also. Now to show that f is a function or not, let us see that fx is equal to x square as well as 2x, and 2 is the common point. So we select x is equal to 2 and put in both fx is equal to x square and fx is equal to 2x. We are getting 4 and 4. So in both cases 2 is going to 4, and this is called f2. So the value of f2 is same. One pre-image has one image, so the value of f2 is same. So this is a function. Again equivalent question. Again 3 is common, so we select x is equal to 3 for testing. So gx is equal to x square as well as 2x. So g3 is 9 as well as 6. So 3 is going to 6, 3 is going to, just see, g3 is 9 and g3 is 6. So 3 is going to 6, 3 is going to 9 also. So this is not a function. One pre-image has double image, hence gx is not a function. Now you know how to find out this. No need to discuss. This is the most urgent problem. Find domain and range of this. Write y is equal to this. Since radicand is more than 0, so x square minus 4 more than 0, factorize it. Display the two terminal points on number line, and sign scheme plus minus then plus, permanent sign scheme. Now you need greater than 0, means minus infinity to minus 2 and 2 to infinity. This will be the domain. Domain is answered. Now for range, y is equal to this. Now keep x in left. Keep x in left and find the value of x, this. Again radicand is more than equal to 0, so y square plus 4 is more than equal to 0. So factorization is not possible because this is true for all value of y. So range is equal to all y, but remember it that y is root over x square minus 4. So y is always greater than 0, and this tells that y is any real number. So finally y is greater than 0, so y is equal to 0 to infinite is the range. Now this question 22, find the value of range. Just see how to find out the range. This is the question. X goes to x square by 1 plus x square. This is called fx and also called y. Now y is equal to this. To find range, we express x square cross multiply, and we find the value of x is equal to this. Since radicand is more than equal to 0, so write y minus 0 by 1 minus 0 more than 0. But remember that denominator is not in a standard form. So we have changed the sign of denominator, then this sign will also be changed. Now display the number on the number line, the two critical points 0 and 1. Follow the sign scheme, plus 2, plus then minus then plus. You have to select less than 0 means this to this, and since denominator is not 0, so y is never 1, y is not darkened. So this is your range. Range is over. If you are interested, you can find the domain here. How to find domain is also explained here. Since y is equal to this, so denominator is not 0, and 1 plus x square is not 0. X does not exist, which will make the denominator 0. So we can take any value of x for domain. So domain is any real number.